how to find percentage composition of elements present in a compound. What percent of particular element is present in a molecule of a compound? So last class we learned that. Now today we'll be learning how to find empirical formula of a compound, of a molecule of a compound. So how to find empirical formula of a compound? Determination of empirical formula. I think you know what is empirical formula. Empirical formula is the simplest whole number ratio of atoms of element in a molecule. Simplest whole number ratio of atoms of element in a molecule. For example, you know molecular formula of glucose, that is C6H12O6. So this is molecular formula of a compound, molecular formula. But if I have to write empirical formula, then how I will write? Here I know that the ratio is 6:12:6. C:/H:/O is 6:12:6. But this is not the simplest whole number ratio. So this can be reduced. This can be simplified, and this can be simplified as 1:2:1. So this is the simplest whole number ratio. That means its empirical formula will be C1H2O1. This will be its empirical formula. So I think you understood what is empirical formula. Empirical formula is the simplest whole number ratio of atoms of element in a molecule. Now today we will be learning how to determine empirical formula of a compound. So there are some steps which we need to follow in order to find empirical formula of a compound. Sometimes percentage weight of oxygen or carbon or hydrogen is not given. So sometimes what happens is percentage weight of oxygen or carbon or hydrogen is not given. So how can we calculate them? Then what we have to do is, whatever percentage weight of other elements is given, we have to add all the percentage weight of rest of the elements. Then we need to subtract that sum of the percentage weight from 100, and we will get percentage weight of the element for which it is not given. For example, it may be carbon, it may be hydrogen, it may be oxygen. So this is the way how we find. So how do we find percentage weight of element for which it is not given? By subtracting some of the percentage weight from 100. Then this will be doing by example. I will do example for this so that it will be clear for you. But before that, we'll be seeing how to get empirical formula, these steps, all these steps. Then step number 2. Ratio of number of atoms. So how to find the ratio of number of atoms? So ratio of number of atoms is equal to its percentage weight by its atomic weight. Percentage weight by its atomic weight. For example, percentage weight of oxygen is 16. Percentage weight of oxygen is 16%. Then we have to divide it by its atomic weight, which is also 16. Then how much we get? 1. So ratio, that means number of atom. Number of atom present in that particular is 1. The particular molecule is 1. So this is the way how we find ratio of number of atoms. Then after finding this ratio of number of atoms, what we do is we go to step 4 directly. But sometimes what happens is, there are molecules which contain water of crystallization, and for those molecules, how to find how many number of water molecules are there. So ratio of number of water molecules can be calculated by dividing its percentage weight by weight of water, that is 18. So for example, if percentage weight of water is given 55%, then you divide this 55% by weight of water, that is 18, then how much you will get? That will be the approximate number of molecules of water present in a molecule. So step number 2 and step number 3 are somewhat similar. Here we will be finding the ratio of number of different atoms present in the molecule. Here we will be finding ratio of number of water molecules present in a molecule. Then after that, to get a whole number ratio of atoms of different atom or water molecule, the numbers obtained in steps 2 and 3, whatever numbers will be obtaining in step number 2 and 3 are divided by the smallest number. So in order to get whole number ratio of atoms or water molecules, what we do? We simply multiply, we simply divide the numbers that we are getting in step number 2 and 3 by the smallest number, so that we get the whole number. And if we do not get this whole number here, so for example, by dividing the number of atoms or molecules that we got in step 2 and 3 by the smallest number, sometime I may get decimal. Sometime I may get decimal. If it is 1.1, then you can ignore 0.1 and can write 1. But if it is 1.5, then you cannot ignore. So in that case, what you will do? You will multiply it by 2 so that you will get a simplest whole number ratio. Simplest whole number ratio. So this is the way how we get a whole number ratio. And finally, after getting that whole number ratio, what we do is empirical formula is now derived by writing the symbols of various elements side by side with the number of atoms of each one as the subscript to the lower right of its symbol. Then finally, after getting this whole number ratio, we will be writing symbol of each element present in a molecule, and then towards the lower right of symbol will be writing this number what we got in step number 4 as subscript. This will become empirical formula. This will become empirical formula, and this will be doing by doing some example. This will be clear to you by doing some example. So let's do some example in order to understand how to determination of empirical formula better. So first of all, I'll be doing one example which will clear step number 1 of this. Step number not a step number 1, but yes, if molecular formula is there, then how to find empirical formula? First of all, we'll do that. If molecular formula is given, then how to find empirical formula? Example number 4 of your textbook, the molecular formula of an organic acid is CH3COOH. What is its empirical formula? What is its empirical formula? So you have to find empirical formula. The molecular formula of an organic acid is given. So solution molecular formula directly write molecular formula. What is the molecular formula given here? CH3COOH. This is the molecular formula. Now, in order to find empirical formula, you just count how many number of atoms of particular element is present in the molecule. So you can see here how many carbon atoms are there? 1, and here also 1. So total number of carbon atoms is 2. C 2. Then how many hydrogen atoms are there? 3 and 1 4. So he is writing C2 at 4. And then oxygen, how many? O2. So you can write O2. This is molecular formula. And I have arranged this in such a way that we will get the number of atoms of each element present in the molecule. So this is your molecular formula. Now what you can write is ratio. Therefore, ratio of C, then H and O is, so what is the ratio? What is the ratio of carbon to hydrogen to oxygen? So it is 2:4:2. Do you think this is the simplest whole number ratio? No. All these can be divided by 2. All this can be divided by 2. So we'll be finding the simplest ratio. Simplest ratio. We'll be finding the simplest ratio. Simplest ratio is divide all by 2. So 1:2:1. 1:2:1. Therefore, now what is empirical formula? Simplest ratio. What is the empirical formula? Simplest ratio of atoms of element present in a molecule. So we got it. Now what you can write? Empirical formula. Empirical formula is, now you write the symbols C and then H and then O. CHO. Yes, step number 5. You will be writing the symbol of elements present in the molecule. Then, what is the simplest ratio we got here? 1:1. And this 1 is for carbon, so you will be writing on the lower right. Lower right of the symbol. C1, H2O1. This becomes your empirical formula. And what we have learned while writing molecular formula is you can ignore the subscript if it is 1. That means you can write that is CH2O. CH2O is empirical formula of this organic acid. So this is the empirical formula of this organic acid. This is how we can determine empirical formula if molecular formula is given. Then next example, how to find empirical formula if percentage weight of elements present in a molecule is given. That is example number 5. Example number 5. There are two examples, A and B in that, but I'll be doing B. 5B. So what is the question given here? Find the empirical formula of the compound with the following percentage composition. Find empirical formula, I'm writing in short, of the compound with the following percentage compositions. Percentage compositions. So for B, what is there? Mg is equal to 9.76% magnesium, then sulfur 13.01% sulfur, then oxygen 26.01%, then water H2O is equal to 51.22%. Okay, that means here we have water molecule as well. Here we have water of crystallization, water molecule as well. Okay, so here first of all we will go to step number 1. So what was the step number 1? Percentage weight of each element is given or not. First of all we will check that. If it is not given, then we will subtract sum of the percentage weight from 100 to get percentage weight of the element for which it is not given. So here we can see magnesium is there, sulfur is there, oxygen is there, and water molecule is there. So everything is there. Now step number 1 is clear. Now step number 2. So what is step number 2? Step number 2 is you have to find ratio of number of atoms. Ratio of number of atoms. And step number 3, ratio of number of water molecules. So that you will be doing. So for this, what you will do is, it will be good if you can draw a table. If you can draw a table having how many columns? 5 columns. 5 columns. Draw a table with 5 columns. 2, 3, 4 and 5. 5 columns. Then in this column you will be writing element or compound. Element or compound. And then here you will be writing percentage composition. Percentage composition. Here you will be writing ratio of number of atoms. Oh, atomic mass. Atomic or molecular mass. Atomic or molecular mass. Then you will be writing atomic ratio. Ratio of atoms or molecules. Ratio of atoms or molecules. And then here you will be writing the simplest ratio. Simplest ratio. Okay. Now here you will be writing element or compound. So how many elements? Write first magnesium. Okay. Then write sulfur. Then oxygen. Then water molecule. This is the way how you do. Symbol of elements or formula of the molecule, water molecule. Then MgSO water. Okay. Now percentage of magnesium given here is 9.76, sulfur 13.01, oxygen 26.01, then water 51.22. When you add all this, you need to get 100%. When you add this, you need to get 100%. Okay. Then, after writing percentage composition, what you will do? Atomic or molecular mass. So, what is the atomic mass of magnesium? Now, I think if it is given, then it's okay. If it is not given, you must be knowing. You must be knowing the atomic weight or molecular weight. So atomic weight of magnesium we know is 24. What is it? 24. And atomic weight of sulfur is 32. Atomic weight of oxygen is 16. and molecular weight of water is 18. So this is not given in the question. That means you need to know atomic weight of some common elements which we generally use for doing numericals and all. So magnesium is 24, sulfur is 32, oxygen is 16, water is 18. Now this is step number 1. Then step number 2, what we have to do for finding ratio of atoms. So ratio of number of atoms is equal to percentage weight by atomic weight. Percentage weight by atomic weight. So what percent of magnesium is here? 9.76. So 9.76 divided by, what is its atomic weight? 24. 24. So how much you will get? How much you will get? Yes, you can calculate it. You will be getting 0.406. 0.406 you will be getting. Okay. Then for this, what is the percentage? 13.01. 13.01 divided by 32. Then how much you will get for this? You will be getting 0.406 only. 0.406. Okay. Then for oxygen, 26.01 divided by 16. Here you will be getting 1.625. 1.625. 1.625. And here 51.22 divided by 18, and you will be getting 2.84. You will be getting 2.84. Okay. These are the ratio of atoms or ratio of molecules. Now, this is step number 2 to find ratio of number of atoms of each element present in a molecule. This is step number 3. There is water molecule, then find number of water molecules by dividing its percentage weight by weight of water. Now step number 2 and step number 3 is done. Now what is there in step number 4? Divide whatever number ratio of atoms or molecules you are getting in step number 2 and 3 by the smallest number. Now among this, which is the smallest number? Among this, which is the smallest number? This is 0.4, this is 0.4, and this is 1.6, this is 2.8. So this is the smallest. These two are the smallest, you can take in. That means divide all these ratio by the smallest number. So 0.406 divided by 0.406, you will be getting 1. This also has to be divided by that smallest number. So 0.406 divided by 0.406, and we will be getting 1. This 1.625 and divided by 0.406. Here you will be getting roughly 4. How much you will be getting? 4. 4 fours are 16, rough idea. Okay, then 2.84 divided by 0.406. So this is 28. If you ignore decimal, this is 28 and this is 4. So 4 how many makes 28? 7. So 7. Now we got simplest ratio. We got the simplest ratio, and that is 1147. 1147. Then you write, therefore the empirical formula of the compound is, so write the symbols Mg, then S, then O, then water. Got it? Write the symbols Mg, then S, then O in serially like this. Mg, S, O, and water. Now, we are in step number 5. Step number 5. Now, what do we have to do? We wrote the symbols or formula of the atoms or molecules. Now, whatever simplest ratio we have got here, this we have to write on the lower right of the symbol, of the respective symbol. So for magnesium, what is the ratio we got? 1. So Mg 1. For sulfur, what is the ratio we got? 1. S 1. For oxygen, what is the ratio we got? 4. So right here 4. Dot. Whenever there is a water molecule, we write dot. So dot. Then number of water molecules. What is the simple ratio for water molecule? 7. So we'll be writing here in front because this is number of molecules. For number of atoms, you write as the lower right subscript. But for molecules, you write in front of the molecule. For molecules, you write in front of the molecule. So, if you simplify this, if you write it in a very simple way, ignoring 1, then it will be MgSO4 dot 7H2O is empirical formula of the compound. So, this is how we calculate empirical formula of a compound. Now, another example is there, that is all an organic compound has oxygen 26.24% and hydrogen 4.92%. Find its empirical formula. Find its empirical formula. So, example number 6. What is the question? An organic compound has oxygen how much? 26.24%. 26.24%. And hydrogen how much? 4.92%. 4.92%. Find its empirical formula. Find its empirical formula. Okay. So as soon as you see the question, your first duty is add all the percentage. Add all the percentage. On the rough side, you add the percentage. So 26.24 and then 4.9. This is 6, 11, 4 to 6, 9, 11, 4, 6, 4, 10, 1, 11, and then this is 3. So only 31.16% is there. That means huge percentage weight is missing. So what was there in step number 1? Sometime percentage weight of either carbon or hydrogen or oxygen is not given. Especially if the compound is organic compound. Then how do we find percentage weight of the element whose percentage weight is not given? 100 minus sum of the percentage weight of other elements. Now organic compound means there must be carbon. There is no organic compound without carbon. There is no organic compound without carbon, mind you. And there is Nothing mentioned like carbon. That means what is missing? Carbon is missing. So how do you find? Solution percentage weight of carbon in the compound, in the organic compound. In this organic compound, you can write in this organic compound is equal to 100 minus how much you got? 31.16. 31.16%. So subtract 100 minus 31.16. So 4. Then this is 9. 9 minus 1, 8. And then this is 9, 1, 8. And then this is 968. So carbon must be 68.84%. So what is percentage weight of carbon? 68.84. Then it is easy now. Again follow the same process. Follow the same process that we did just before this. So again you make a table with 5 columns. Make table with 5 columns. 1, 2, 3, 4 and 5. Then here is percentage of element. Since you can see here is no water molecule, so you can simply write element only. Then here you can write percentage composition. Instead you can write percentage only, percentage or percentage composition. Here you will be writing atomic weight. Since there is no molecule, so why to write molecular weight? If there is molecule, you can write molecular weight as well. So this is atomic weight. Then here you can write ratio of atoms. Ratio of atoms. Since there is no molecule, you don't write ratio of molecules, or number of atoms also you can write. This is ratio of atoms or number of atoms, and you can write. Then comes simplest ratio. Simplest ratio. Simplest ratio. After this, you can write whatever elements are present, their symbols you need to write. So write carbon, then you can write hydrogen, and then you can write oxygen. Any you can write. It's up to you. It's up to you. So carbon, hydrogen, oxygen. Okay. But since it is organic compound, so generally what we do is while writing the formula for organic compound, we write carbon in front, then hydrogen, then oxygen. So this is the series for writing organic, for formula for organic compound, we will be writing in this series. So it is good if you follow the series. So carbon, what is the percentage? 68.84. Then hydrogen? Hydrogen 4.92. 4.92. Then oxygen 26.24. Then atomic weight of carbon is 12, hydrogen is 1, and oxygen is 16. Then find number of atoms or ratio of atoms. So then how will you find number of atoms or ratio of atoms? Percentage weight divided by atomic weight. So 68.84 divided by 12. 68.84 divided by 12. So how much you will be getting? How much you will be getting? You will be getting 5.74. How much you will be getting? 5.74. You can write here 5.74. Then 4.92 divided by 1, you will be getting same 4.92. 4.92. And then 26.24 divided by 16. How much you will be getting? Yes, 1.64. 1.64. 4. It will be good if you can do like this. Yes. So this is carbon 5.74 you are getting number of atoms, then hydrogen rough number of atoms you are getting 4.92, then oxygen you are getting 1.64. So among this ratio of atoms, number of atoms, which you are getting the smallest, this is the smallest. So divide all the number of atoms or ratio of atoms by this smallest number. So it is 5.74 divided by 1.64. So how much you will be getting? Yes, how much you will be getting? You will be getting 3.5. 3.5. And then this 4.92 divided by 1.64. So how much you will be getting here? Here you will be getting 3. Then 1.64 divided by 1.64 you will be getting 1. Now, question is, this 0.5 you cannot ignore. You cannot ignore. So, and this is not the simplest whole number ratio also. This is not a whole number. This is not whole number. This is decimal. So, how to convert this into whole number? So, you have to multiply. If you can multiply this by 2, that means 3.5 into 2, you will be getting 7. You will be getting 7, which is your whole number. This is whole number. This is whole number. 7. That means you have to multiply this by 2. And you cannot multiply this only by 2, you have to multiply whole by 2. That means, what you will be getting? What you will be getting? Yes? Or simply you can write here, multiply 3.5, 3, 1 by 2. By 2. In order to change into whole number. In order to change into whole number. Whole number. So how much you will getting then? Thus, the ratio of carbon to hydrogen to oxygen is, now 2 into 3.5 becomes 7 is 2. Hydrogen is becoming 6 is 2. Oxygen is becoming 2. So the ratio has become now 7 is to 6 is to 2. 7 is to 6 is to 2. Therefore, its empirical formula is, so what is its empirical formula then? What is its empirical formula then? Write the symbol CHO. CHO. What is the number of, what is the simplest ratio of carbon? 7. So write C7, H6, O2. This is empirical formula. C7, H6, O2. C7, H6, O2. Similarly, we can find molecular formula as well. So, next class we'll be finding molecular formula. How to determine molecular formula? Next class we'll be doing. Till then, you practice all the numericals solved in your book and the numericals that is present in your questions, and those numericals related to percentage composition, related to this one, vapor density, then empirical formula that has come in previous year's question, ICSE questions. Okay, till then, stay safe, stay healthy. Thank you.